Okay, we're going on to differentiation using parametrics. We can tell this is differentiation. It asks for a gradient, and this is a parabola. It's a curve. So we need dy by dx. Okay, so we're going to differentiate. But I'm starting with x and y in terms of t. So when I differentiate, t squared differentiates to 2t, fair enough. But what is that? It's not dy by dx. I've differentiated x, and it's in terms of t. So this is dx by dt. Okay, fair enough. I can do the same with this. Y is 2t, so dy by dt, differentiating that, equals 2. So I've got two derivatives, but neither of them is the one I really want, which is dy by dx. Okay, now there's a rule here that you learn, but what we do is we use a version of the chain rule. I need to use dy by dt, and we know from the chain rule that we can multiply by another derivative. We want this dt to cancel, so I need a dt on the top, and I want the dx on the bottom, so I need the other derivative to be dt by dx. But this is just the reciprocal of dx by dt. So in fact what we do is dy by dt divided by dx by dt, which is what it says up here. Okay, so that's where that rule comes from, so we just have to use it. So when you do these, you set up dx by dt and dy by dt, get the division the right way up. You can just say dy by dx equals the y derivative on the top and the x derivative on the bottom, which is 1 over t. So notice we get dy by dx, but in fact it hasn't got x's or y's in it. It comes out in terms of t. So now we've got another puzzle to solve. So normally we'd just put our x value into dy by dx because it comes out in terms of x normally. With the implicit ones it came out in terms of x and y. Now it comes out in terms of t. I need to know what value of t generates this point. Okay, so how do I get the point 96? Well, I need my x to be 9, so x is 9. Is got to be my t squared value, and y, which is 6, has got to be my value of y is 2t. So I could attack either of these first. Okay, in fact the second one makes it very clear that if 2t is 6, then t's got to be 3. Now if I'd worked from x, t squared being 9 would have actually given me t equals plus or minus 3. So it's possible that you'll get a t value that works for x but not for y, or vice versa. So you should really check, once you've found t from the easier of the two, you should just check your solution works in the other one. Okay, but the solution t is minus 3 may work for x, but it doesn't work for y, so we're just not interested. So therefore t is 3 is the only value we're interested in, and my dy by dx, my gradient, which is what I was asked to find, is, I know dy by dx is 1 over t, so it's 1 over 3, and that is my answer for dy by dx at that point.